All right, let's jump right in. Today we're doing an architect's overview of this new tool, OpenYak. The requirement here is pretty simple. We need to understand the stack. And the whole point is that it's an AI agent designed to run directly on your local machine. So let's break down how it's built. Look, we've all been there, right? You're facing this massive bottleneck. Your local environment is just a sea of unstructured data, and you think about using a cloud AI, but that just opens up a huge can of worms with security and privacy. This isn't just about a messy workflow. It's a real architectural problem and how we handle our own information. So you're kind of stuck between a rock and a hard place. You either do all this tedious manual work yourself, or you risk your data with cloud-based solutions. We need a system that can automate all this stuff without creating a brand new set of vulnerabilities. Okay, so this brings us to the first major function of the OpenYak architecture, automated workspace management. This is all about building a resilient system that brings some sanity directly to your local file system. So let's look at the implementation. Basically, what is happening under the hood is this really clean three-step process. First, the agent just scans a folder you point it to. Then it uses its AI to figure out what each file is. Is it an invoice, a receipt, a report, whatever. And finally, it renames and organizes everything based on rules you set. It creates a simple and, more importantly, an auditable workflow. And here's the result. Instead of some useless file name like invar-final03.pdf, you get a standardized searchable name like 2026-3-north energy.pdf. And this isn't just about being neat. It's about creating a structured, predictable data environment right on your own machine. The architecture is also smart enough to handle more complex stuff like team operations. It can pull data from all kinds of different file formats, PDFs, docx files, CSVs, and just merge it all into a single structured brief. It can even pull out action items and assign owners, which, automates a huge chunk of project management overhead. Okay, let's move to the next key component, which is where this really starts to build: secure local data analysis. The big architectural decision here was to keep all the processing on your device. That has massive implications for both privacy and speed. This quote from the source material just nails it. You get all the cool benefits of AI-driven analysis, spotting trends, finding anomalies, but you completely eliminate the security risks that come with third-party data processing. And here's a really concrete example of what that local analysis can spit out. It can parse a messy expense sheet and just give you this clean summary table, even highlighting week-over-week changes. This is actionable intelligence, and it's all generated inside an environment you already trust, your own computer. Now, a powerful local agent is great, but it's useless if it's an island. So the next piece of the architecture we have to talk about is connectivity, how OpenYak actually plugs into your existing tools and enables remote workflows. And get this, the system comes with 46 pre-configured connectors right out of the box. This is a huge architectural decision. It means the system was designed for interoperability from day one, not as some feature that was bolted on later. And you can see here, this diagram shows the range of those connectors. They cover the whole shebang, from project management tools like Jira to communication apps like Slack, all the way to CRMs like Salesforce. This lets OpenYak act as a central hub for your entire digital workspace, which cuts down on all that context switching and makes you more efficient. Now, check out the remote access part. You can expose your local AI agent over a secure tunnel just by scanning a QR code with your phone. From an architectural standpoint, this is a very elegant solution. It gives you remote access without any centralized hosting, which keeps that whole privacy-first model intact. So what's the secret sauce behind all of this contextual awareness? Let's dig into the core technical differentiator that makes this AI actually useful for specific projects. It's something they call workspace memory. Workspace memory is implemented as a simple markdown file that lives inside each project folder. This little file gives the AI all the context, user preferences, and project history it needs. That means it doesn't have to relearn everything from scratch every single time. Here's a perfect example of how it works. You can specify your preferences like, hey, always give me concise bullet point summaries, and then add project-specific context like the Q1 budget cap is $45,000. The AI will just automatically use this information in every single response for that project. It's simple, but so effective. This is so incredibly important from a systems perspective. As we use AI more and more, we have to be careful about the technical debt we're introducing. The cost of having to fix things when the AI gets it wrong. Workspace memory is the mechanism designed to fight this. It makes sure the AI's answers are always aligned with your project goals, which helps maintain quality over time. So, if we strip it all down to the studs, the architecture of OpenYak is really built on three core pillars. It's private by design, it's local by default, and it's remote ready for the way we work today. That's the main takeaway. And that really leaves us with one final question to think about. Once you have this kind of system deployed in your own local environment, what bottlenecks could you finally get rid of? What could you build or automate if your AI lives securely right there on your own desktop? It's definitely something to think about.